Good morning to everyone. I appreciate you spending time with us this fine morning. I know it's been a hot one all over this state, and I was enjoying the weekend as much as you you guys probably were as well. But boy, I tell you what, I am appreciating this air conditioning today. But anyway, we'll go ahead and get started since I know we have a time constraint. I do believe we have to be done by 11:30. That way we can have the following presenters be able to get onto our web share here. But anyway, today we're going over improving educational outcomes and enhancing school connectivity with a focus toward demystifying Wi-Fi 6. Just to introduce myself, well, it would help if I get over here. Just to introduce myself, my name is John Childers. I'm the Vice President of Verteks Consulting here. I've been here going on 22 years. And during that time frame, I've handled quite a few projects. I started out as an engineer here back in 1998 and worked my way up through management, being both sales and service management, and now I'm the vice president of the company. During that time, I've handled thousands of projects ranging all over the state of Florida here. And my specific focus now is local and state government and education. So you can use me as an additional resource if you have any questions about what other counties are doing as far as education and tackling the ongoing challenges that we're facing, which are science fiction. If you were talking about this about 8 months ago, it would be a science fiction episode. But the challenges that we have faced and conquered just in the past few months have been incredible. But I want to introduce Verteks Consulting. Who is Verteks Consulting? We're a Florida-based company. We service the entire state of Florida. As you'll see in future slides, the types of companies that are the types of organizations that we support. We do quite a bit of stuff, and we've been recognized by our peers, not only our peers but also our manufacturers that we represent as leading in the state of Florida with the technologies such as the Ruckus networking, which is what we're talking about today, and more specifically Wi-Fi 6. Also Microsoft, Mitel, Unified Communications, VMware, WatchGuard, HPE, just to name a few. We do quite a few things, not only just wireless networking, but we do networking, unified communications, security systems as far as perimeter security or network security. We do servers and hyperconverged devices, storage devices. So they get you kind of a flavor of Verteks Consulting. We've been doing this since 1996, so we're a very mature company as far as technology goes, and as far as being in the community, and especially the state of Florida. So just to kind of give you a flavor of the type of people that we help support currently, just here in the state of Florida, we have quite a few school boards that we support. We got Martin County, Citrus County, Jackson County, Walton County, Holmes County, DeSoto, and Washington, just to name a few. We also have some higher education with Pensacola State College, New College of Florida, to name a few, and then we have some private education as well, or private schools that we help support. Also with that, we also have cities and counties that we support. Just a few of these ranged all over the state, all the way from the city of Pensacola up in the Panhandle, all the way down to, let's see here, let's get down near Miami. Let's city of Aventura, there you go, on the right-hand side. But it ranges the entire state and counties as well, with Citrus County, Flagler County. We also have utilities and government or federal accounts such as NOAA and U.S. Fish and Wildlife Service that we support. With that, I'm proud to say that I help support over 82 local and state government agencies here in the state of Florida. And during my time, I was specialized in that. Let's go ahead and just kind of touch on what we're here for, and what you're here as far as attending the web conference is to talk about the challenges that we see coming up, also the challenges that we have seen in the past. And I want to take a moment here and kind of laugh at this slide. This was a slide that we generated a little bit before, right around February timeframe. Yeah, the complex challenges have multiplied, have they not? Kind of just sit there and think about, again, what I said was science fiction just 9 months ago is now a reality. And I don't think that what we have accomplished has been told. And I want to take a moment, and because I work so closely with all of you, and all the organizations such as yours, to kind of take a look at what we've done and the types of things that's popped up recently. And I want to commend you and congratulate you on the Herculean effort that you and your staff have done. This is not getting any coverage, but I can't think of any profession that's been asked to change completely on a dime. I don't mean within a year. I don't mean within months. I'm talking days. And we have taken our whole infrastructure and put it outside of our organization. We've been tasked with giving students education while they're at home versus in the classroom. And to do this in such a short time frame is unprecedented. So I want to take a moment to congratulate you, just to take a moment to think about what you have accomplished and have that sense of accomplishment, and to say thank you. We are here in the state of Florida. Our children go to your schools, and I appreciate it. We appreciate it. You've done an incredible job. So with that, we'll go on and talk about a few complex challenges and just kind of what our current challenges are. Just reliable classroom connections, community connectivity for digital equity. We got to make sure that everybody has a chance at education. Distance learning connectivity. Yeah. The fact that we are here in a web conference versus being inside of a hotel kind of demonstrates how how everything has changed just in 6 months, 4 months. Also, I got an example here, and I was talking with a couple other school boards, Jackson being one of them, setting up parking lots for outdoor site coverage of Wi-Fi. That way they can get internet. And I have an example there. This is just something that we didn't think about that we're going to need. And now it's here. Securing wireless devices. DeSoto County had to deploy 3,000 devices within the matter of 2 or 3 days. Marion County had to do 10,000. I know. Just take a look at what you had to do and put these devices in the hands of the students, and then also have existing devices and everything, and people at home. You have teachers at home, and you're having to secure the network from these people being at home. So you're having to secure wireless devices and wired devices across your expanded network now. Securing campus perimeter and monitoring lockdowns. This is something that's a holdover, kind of almost in the distant past now, with everything that just happened. But we're still having to worry about securing our campuses from threats, people coming on and wanting to do harm to the locations. Also, not only physically, but via the web. We have your cyber hackers and cyber criminals taking our networks and turning them into profit centers for them. We're having to worry about that as well. And then with new schools coming on board and everything, I'm starting to see a lot of IoT devices such as HVAC and that sort of stuff coming online. And as far as what we have to handle via both network and wireless networking. And then one that that I didn't think about, but came up in a couple conferences that I attended just this past November all the way through January, is vape detection and how serious that's become in certain areas, and wanting to combat the uses of vape devices, and then also anti-bullying, being able to monitor the bathrooms for fights, for outbreaks of violence, and being able to be notified whenever that's going on without having a bathroom monitor there the whole time. But taking a look at all this is doing more with less or the same. We've been asked to take additional devices, some stuff that we've never thought that we would have to do or have to purchase or have to get. We've had to take all these devices and bring them onto our network in such a short amount of time. But the thing is the budgets are what the budgets are, and we're just having to shift how we're spending our budgets on new technology, versus keeping the existing technology up. The amount of devices that's going into the classroom and the amount of devices that's going out into the field is just it's exploded, and it has a lot to do with what's going on now, but it also has to do with the the way that we deliver our curriculum now and the amount of devices that's in each classroom. So let me give you a couple of examples of stuff that we've worked on and helped with. Just recently, Holmes County School District had to replace their aging Wi-Fi access points. Reason being is access points really, they were doing the job that they were designed to do. The problem is now we have such a propensity or such an explosion in the amount of devices that are in each classroom, whether it be a smart board, whether it be tablet devices or just regular mobile devices. Also, the schools now are being designed not to have wires inside of the walls any longer. Everything's going wireless, and you have all these HVAC devices and IoT devices and everything coming on, and there's such an explosion. We're talking triple the amount of explosion in the amount of devices that you would have even expected at the high point, and now we're having to support them. So what they had to do is they had to replace 7 schools worth of access points, but they couldn't increase the amount of access points. They had to look for technology that would be able to replace the existing APs on a one-to-one basis and be able to support the explosion in the amount of devices. And then also take a look at making sure that we didn't have to recable or run new cables, because that's also an unexpected expense, having to run this networking to support these access points. So with that, they purchased 163 access points in over 7 schools and was able to support the explosion of the amount of devices that are coming in per classroom without having to add access points to do so. So this is an example of doing more with the same. I think that the people there in Holmes County are extremely pleased with the solution that they've selected, and I think it's also a good example of using current technology to answer the challenge that you're facing, using current technology to increase the amount of networking that you have inside of your schools. So I commend them for doing this, and this was a project that I'm proud to be a part of. Also, another one really crazy, Will Rios over at Ocala Fiber, the city of Ocala Electric. Ocala Fiber was tasked with, or asked by the county to help with a solution that they ran across. And again, having to send all your students home, and a lot of people that are in rural counties can definitely shake your head. Yes, this is exactly the type of thing that I ran into and I'm experiencing. Marion County is not a rural county. We have quite a population here in the center part of the state, and there's a lot of area that has access to free Wi-Fi, free internet. And especially if you're in the city or in one of the cities that's inside of this county, you can find or readily find areas that you can pick up a internet signal. So sending all these kids home and stuff, that, and also there's internet via cable companies, Cox Cable, Comcast, so on and so forth, the telephone companies. So most of the areas here have available broadband internet, but there's areas here that have no internet. What I mean by that, Marion County borders the Ocala National Forest. There is no internet out there, and there's tons of people out there. There's schools out there, and especially if you're talking about Fort McCoy and those sorts of areas that the people want internet, but the service is just not there. The signal's not there. There's not reliable broadband internet. Most of their television comes from a satellite dish, and so does their internet. Their internet comes from a satellite dish. Or if they're lucky to be near a tower, a 4G tower, they can get some internet from that, but it's not reliable, and it's not something that you can count on. And the students needed these types of connections in these rural areas. Again, everyone that's probably on here has an area inside of their county that has this type of challenge. It's not the fact that the people there can't afford it or don't want it. It's just that the infrastructure is not there. And so what they did is they went through and said, okay, our schools need additional internet bandwidth. So they reached out to Ocala Fiber, which is an internet service provider, and said, okay, via our existing fiber network, give us additional internet so we can provide these services and stuff for our remote workers and our students to provide the curriculum. And they were able to do that, but one of the things that they ran into, again, is the fact that there was no internet, no reliable broadband internet to where they could go and download their weekly curriculum and upload their classwork. So what they did is Ocala, the city of Ocala had some access points that they were using to light up their downtown area for citizen service, and they had some outdoor devices, and they said, you know something, where you have these sitting over here, we don't need them right this second. Let's light up your parking lots. Let's go to 9 locations in these rural areas and light them up to where you can drive in, download your curriculum, and upload your classwork, and allow the parents to come and drive their students so that way they can pick up their classwork. So this was a thundering success, and Will's extremely proud of this. This is Ocala Fiber. It was in the newspaper as well, something that we help support as well, and something I think that current, again, just an example of thinking outside the box and tackling these challenges that we thought, again, were science fiction just 9 months ago, 8 months ago. So let's get to exactly why we're here. We got 802.11ax, or Wi-Fi 6 is what I like to call it, because it's simpler to say, and also people can wrap their head around it. We're here to talk about what it is, what it's going to allow us to do, and the technology that's behind it. And I'm not going to get into the deep woods with how many bits per symbol on QAM 256 versus 1028. What the sigma is and what the sign is. I'm not going to get into the weeds like that. I'm just going to give you a high-level view, a simplistic view. That way you can wrap your head around what's the difference between Wi-Fi 5, or aka 802.11ac, and 802.11ax, and what does it mean to me? Why do I need this? What is it? It's another AP. It's going to go faster, right? Is that it? Is that all it is? And that's not it. It's not it by a long shot. It's not about getting bigger throughput, like AC was, and N was, and B, and everything else. It's a completely different way of handling how wireless is delivered to the devices, and you'll see here in a moment. So, what's the harsh realities of Wi-Fi today? What is it that we were asking our Wi-Fi devices or Wi-Fi access points to do? And So with that, Wi-Fi landscape's expanding. We're asking our Wi-Fi devices to do more. We're asking our Wi-Fi devices to support more devices per AP, but we're not increasing the licensed spectrum that they use. So we're asking it to do more with the same. We're asking it to have more throughput with the same amount of licensed spectrum or what I would say bandwidth, but it's wavelength. So Wi-Fi usage is pervasive. We just got done talking about this. Everything's becoming a high density environment. Each classroom's a high density environment. Your libraries are high density environments. You have more devices per AP than ever before. And this is not going to slow down because now we have 20 billion cumulative Wi-Fi devices out there, and there's 3 billion per year that's added, and they're thinking it's going to be around 35 billion devices by 2022. This was a year and a half ago. I'm laughing at this because now with everyone going home and everything that's going on, you got more now. It's gonna go crazy. Just at the house, it's gonna go crazy. To the point now where we typically about 25 connected devices in a typical home. And I was just thinking to myself, and I'm sure that everybody within the sound of my voice here can think about what they were 5 years ago or 3 years ago versus what they have now inside of their house. 5 years ago or 3 years ago, we had our phone and our laptop, maybe our PCs on Wi-Fi, maybe. Most of the time that was wired though. Or even if you had a PC, most people had PCs in. Now they have tablets and all that other stuff. So we're IT guys. I'm an IT guy. I'm a techno geek. I was just thinking about now what I have versus what I had 5 years ago. And now I have speakers using Wi-Fi. I have television using Wi-Fi. I have my garage door using Wi-Fi. I have my front door using Wi-Fi. I have my air conditioning unit using Wi-Fi. I have all the lights in my house using Wi-Fi. I even have fans using Wi-Fi. And I didn't even realize how quickly this had grown inside of my own house. And I'm sure the same thing is happening at your house. Siri and Alexa and all these devices have made it easy for us to control the things in our house. And now I don't even touch a light switch. It's crazy. But now, because of that, we have more devices using up the bandwidth. And this is just in our own homes. Just think about what it is now. I mean, you already know what it's going to be when these students get back and what's happening across the whole spectrum, whether it be business or education or regular local and state government. The amount of devices is just increasing, and we got to do something because the way that Wi-Fi works now is not going to be able to support all these devices. Also, one of the things that I'm glad I put this in here to remind myself, all these devices now, the new devices that are coming out, use massive amount of traffic, but very, very small bits and bytes. So it's screaming out chatter on your wireless network, but it doesn't need very much. It needs just a couple bytes worth of data. It's not like a Netflix 8K or Disney movie at 8K, or I'm sorry, 4K data stream. It's just a device saying, hey, I'm checking in. I'm good to go. I got the temperature 74 degrees. I mean, it's bloop, 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 but it's doing a lot of it. So we got to control this stuff because that's also competing with our devices, our Apple TV devices, our Ruckus, our everything else. Also in the schools, same thing. They're competing with your tablets and all that other stuff, and we got to be able to reduce the chatter on the network. And because of that, we have a diverse mix of applications and QoS requirements because we have the low bandwidth for IoT devices and we have high bandwidth for video and stuff like that. So I'm just briefly go over where we've been since 1999. We had A and B with 11 and 54 megabits in 1999. In 2003, we threw in G. That's Wi-Fi 2, or Wi-Fi 3, I'm sorry, Wi-Fi 3, and went up to 54 megabits and using the 2.4 gigahertz stream. Then we went up to N, introducing MIMO, which is multi-in, multi-out, so you're able to use spatial streams to a single device. Then you had Wi-Fi 5, and this was the first one to crack the gigabit per second barrier with AC, but it used the 5 gigahertz bandwidth. And then now we have AX, which is Wi-Fi 6, was ratified in around 2018. Now it's being certified this year, 2019. So you have devices now certified, Wi-Fi 6 devices, and it uses both the 2.4 gigahertz and the 5 gigahertz stream concurrently. So really, with all of this, we're talking about so many devices on the network now. We're talking about so many things that are contending with getting the data, that really today's network looks like this. It looks like a traffic jam in Orlando on I-4, or Tampa at Dysfunction Junction. But you have stuff going all over the place, and everyone trying to get everything right now, and it just doesn't work. We need to do something different. We need to get some efficiencies. We need to increase the capacity through efficiency. So everything right now is contention based. Everything's screaming, everything needs it now, and it's up to the AP to figure out where to send it. Tomorrow's network is a coordinated network. Think of it as I like this diagram here with scheduled based, also being able to use multiple streams, but I'm thinking it more toward the difference between a hub and a switch. That's how I visualize it. This is the equivalency in Wi-Fi of what happened whenever we had hubs and we replaced them with switches. We were able to increase the capacity of the network by swapping out the device and having a smarter device. So these are the building blocks of Wi-Fi 6. These are the proof of, or the guts of what makes Wi-Fi 6 completely different from Wi-Fi 5 and everything before it. And you have OFDMA, and I'll go over what that is, but it increases the network capacity because you're able to use different frequencies and different subcarriers to support multiple devices during a time slice. And then you have a multi-user MIMO. So you have multiple users being able to use the frequency ranges all at the same time. And I'll go over a little bit more in depth what I mean by that and what the difference between Wi-Fi 5 and everything before it and what Wi-Fi 6 does. Also, power efficiencies. This is something that it's because of the scheduling base with the IoT devices and stuff like that. Now they're only going to be using power whenever they're told by the Wi-Fi device to turn on and communicate with me, and then turn yourself back off. Then, again, I told you I wouldn't get into the QAMs, but we're going to touch just a brief bit on why we're going to get more bandwidth using or more throughput using the same amount of bandwidth. Frequency bandwidth is what I'm talking about here. Because of being able to pack the spectrum now. Also, we'll touch a little bit on long OFDM symbol, what that means, and why outdoor reliability is better. Also, being able to have more throughput with that, and then we'll just touch briefly on BSS coloring. Mainly, I don't see BSS coloring being an issue with my audience today, but what that would be is if you have a multi-site or multi-tenant environment where you have multiple APs all at the same area, and with this BSS coloring, you're able to say, okay, this is my device, this is my network, you can communicate with me and associate with me. The other devices won't crowd the network as far as asking for bandwidth. You don't have to concentrate on them. You can squelch them out, so to speak. So those devices that are on an opposite network, you're not going to have to worry about them taking up your empty cycles. The cycles on the AP that is communicating without really doing anything, as far as communicating with the devices and taking up time slices from the devices that are on your network. So right here, let me just touch, I think on the next one I'm going to OFDM. Yeah. So let me just touch on this long OFDM symbol and what that is. I'm not going to go deep into it, but I'm going to say that AX is now going to allow outdoor communications to happen a lot easier, because OFDM was designed for indoor. It was designed to communicate with devices that are inside of the network, and it's multipath, only bouncing off a couple walls, and the devices being close. So the OFDM symbols, not to get too far into it, but it was a quick packet segment, or it was fast. Didn't have enough time to listen for something to come back. So it was designed for the inside because the device is going to be close to the AP. So if the device is close to the AP, it doesn't take very long for the device to reply to you. Not only that, you don't have as many surfaces that's bouncing back to you and confusing you. They've changed now to a long OFDM symbol. It allows for additional time for the device that's far away from you to reply to you, and it can allow for additional multipaths to come back. It's designed for outdoors, whereas the existing APs now weren't designed for outdoors at all. So that's all I'm going to say about that. So let's go ahead and to OFDM versus OFDMA, and really what I call this drinking from the fire hose. Each and every device gets every frequency per time slice. The device that's communicating per that time slice has every bit of the frequency. So it's very inefficient. It'd be analogous to, okay, you have a highway with 20 lanes in it, but you only allow one car to go down it at any point in time. Very inefficient. That's what we have now with AC and all Wi-Fi 5 and before, is we have a 20-lane highway, but we only allow one car to go down it at any point in time. What OFDMA allows you to do is splice that out to have multiple users use the frequency subcarriers. So if you have, and also be able to per that time slice, design the amount of bandwidth throughput. So we're talking about actual data amount per time slice to go to the devices. So take a look on the right there, and that OFDMA is channelized. And say, for instance, you have two devices at that first time slice there. You have two devices that need a packet for a broadband for a video, and they need the, whatever it is, 10 meg, 20 meg, whatever it is for the video. And so you got two devices that are contending with it and pulling down the video both at the same time, and they both need a large packet. They both can do it during that time slice, instead of one device only allowing it, or it only allowing one device to have the whole entire frequency at one point in time. It allows multiple devices to do so. Then you come to the next time slice, and you have the little bit of purple up there, and maybe that it no longer needs or maybe that's an IoT device, and that IoT device needs a small packet to communicate. Hey, I'm still here, or hey, the temperature's 74 degrees, or hey, the AC just kicked on. And it doesn't need a large packet to send. So you can allow that device to go down, and maybe there's a large download now that's happening, and maybe there's another IoT device. So you're allowing three devices all to communicate during that single time slice. So you can splice up the spectrum, the frequency per time slice, to allow multiple devices to communicate, aka you allow 20 cars to go down the 20-lane highway versus one car to go down the 20-lane highway. That's the difference between OFDM and OFDMA. I think you can start shaking your head. Yes, now I understand what AX is, what Wi-Fi 6, where I'm going to get my increased capacity, where I'm going to be able to support multiple devices now, because now I'm not communicating with one device at any point in time. I'm communicating with multiple devices all at the same time. So again, this factors over to multi-user MIMO. You got single-user MIMO, again, just signifying how many spatial streams I got going on here. And I'm only supporting one device. You can see that top one there. That laptop's getting every one of the spatial streams. So multi-user MIMO now allows the laptop to have more spatial streams or more area to communicate versus the tablet or the IoT device or whatever. You're able to have multiple devices all communicating using the same spatial streams, the same frequency spectrum. You're having multiple devices all communicate at the same time. That increases the efficiency. You're able to support more devices with a single AP now. You're able to have them all supported, all downloading, all at the same time. So let's get into a little bit of also, again, we're able to support multiple devices now. We're able to also shape that frequency bandwidth to allow them to get the amount of data that they need during that time slice. But also, there is an increase in the amount of data that can be put through that frequency. So we have 256 QAM. 256 QAM. This is my propeller head part here. Gets 8 bits per symbol. So as it comes through, each one of those dots gets 8 bits, and you're allowed to have the amount of throughput for your frequency. 1024 seems like it'd be way more, but it's not. Again, we're jamming this stuff into a frequency, so it allows for about 10 bits per symbol. So 10 bits per symbol gets you about a 25% data increase in the throughput, the amount of data that can be thrown through the spectrum. So not only do we allow multiple devices to go through, we're also allowing the spectrum to support more data throughput. So 11, Wi-Fi 6. What if I don't have a Wi-Fi 6 device? What happens then? If I don't have a Wi-Fi 6 device, how will an AX device be able to support me or help me? So with that, because you have devices that are smart, that are coming in, the Wi-Fi devices, and on my next slide here, I'll kind of give you some that are shipping right now. But as those devices, those IoT devices, those laptops, those cell phones, those tablet devices that have Wi-Fi 6 inside of them, as they come on board, they're able to coordinate with the AP and get their data when they need. With that, they're able to get off the network also. So they're very efficient about getting their data. They hop on and they hop off, and the AP recognizes these devices and recognizes that they're efficient devices and gets them on and gets them off quick. So that allows more time slices for devices that don't have that technology. So you're able to support more of those devices now, because now you don't have these screaming devices that are Wi-Fi 6 entering into the stream. They get their stuff, they get off. It's the equivalency, and this is funny, again, because of these times, it's the equivalency to having an app on your phone to order a Mike's subs. You order the app, you walk in, you grab your bag, you've already paid for it, you walk back out. And now everybody else is in the line, and they're waiting for their sandwiches to come up. Same exact thing. The device schedules it itself. It's going to get its data when it wants its data. It comes in, it grabs its packet, it walks back out, and everyone else is in line. So you're able to support multiple devices. So I was sitting there kind of laughing to myself the other day. He's like, you know something? This is Wi-Fi 6 as I'm ordering my sandwich. Anyway, yeah, I am a geek. I admit. But anyway, this gets you an idea of why an AP now can support your network, and why to go to a Wi-Fi 6 AP as you start to swap these things out. So again, one of the biggest questions I have is Wi-Fi 6. When's this stuff coming out? When can I get something? And right now you're shipping, I just took a quick look this morning, and you had the iPhones SEs, the 11s, 11 Pros, and 11 Pro Maxes. You have the Samsung Galaxies. You notice there's a lot of phones here. So a lot of the phones that are shipping out have that Wi-Fi 6 in it. Because they're the phones are the devices now that we go to first. We can't go anywhere anymore without our phones. Our phones are now controlling our cars. Our phones are now controlling our homes. Our phones are controlling our lives. But anyway, with that, as these devices come out, they're the ones that's using a lot of the bandwidth and stuff, and hopping on and hopping off, because they're the prevalent, the device of first choice. Also, you have a lot of the laptops and the Chromebooks coming out. You have the Asus Chromebook Flip 436. You have the Dell XPS 13 just started shipping here in 2020. You have the Spectrum X360, and you have the Lenovo Yoga. And these chipsets are starting to come out and be more prevalent into the space. Intel has quietly launched Wi-Fi 6, and they're putting that stuff into their systems. So you're going to start to see this more and more, and with these devices flying off the shelves as they are, you're going to see these devices be on your network if they're not already there, and start to utilize these types of technologies. But down below too, everybody's starting to ship these things, and Ruckus has been in the forefront pushing Wi-Fi 6 very aggressively. They're one of the first ones to be certified as a Wi-Fi 6 device, and they are the reference. I think their R750 is the reference device for Wi-Fi 7 or Wi-Fi 6. I'm sorry, and they have quite a few devices that have been put out that I've been watching, and that I have going into a couple of my clients right now. But this looks like a product slide, and it is a product slide, but I don't want you to, that's not what I want to use this for. What I want to use this for is to just say, okay, here's the devices that are coming out now, and to exemplify the amount of capacity these things can do now, and the amount of efficiency that they have. So with that, I just kind of going through here. Now, these devices can use 12 spatial streams all simultaneously. What the heck do I mean by that? You've heard of a 4x4 radio. You've heard of a 3x3 radio. Now you have 8x8 radios on 5 gig, and you have 4x4 on 2.4. So you have 12 spatial streams that you can utilize with these APs. It's crazy. These things they're beasts, and they're allowed to do, again, because of the AX standard, multi-user MIMO and OFDMA, and theoretically they can get up to 5 gigahertz throughput. Now, I say theoretically. The AP itself is not going to be your choke point. It's going to be your internet connection or your network connection back to your switch, the cabling. So you got to have switches that can handle that type of throughput. So again, theoretically is what I'm saying, but again, you have to have the back end to be able to support it, and you don't have to have a huge amount of switches and all this other stuff. You don't have to replace all this stuff right now. But I'm just I wanted to show you, hey, these things, your APs are going to be able to throw a lot of throughput through them and do this efficiently. And it's all because of this Wi-Fi 6 standard. Ruckus is, again, the brand that we have settled on just because of the success that we've had with our clients. And being able to support and solve their challenges of being able to get multiple devices on the network all at the same time. But with these devices, take a look at that bottom line. 1,000 clients. I'll say that one more time. 1,000 clients. Again, this is theoretical because you have to worry about how much bandwidth. Now you're having to worry about the bandwidth. You're not having to worry about the AP anymore. You're having to worry about how much bandwidth you can give them. So with that, this just kind of shows you these devices are out there. They're able to support multiple devices. They're able to get more throughput because of the technology. And really what Wi-Fi 6 is all about is not about throughput, the amount of data that goes through it. It's about efficiency. It's all about efficiency, all about being able to support multiple devices and getting the devices the data that they need as quickly as they need it. This kind of goes over. I think we've got about 4 more minutes here. So let me just go through here and touch on this. Again, I don't want to gloss over this, but the blue one is, these are the same series of APs. You have a 720 versus a 730. Just kind of going over how much data throughput that you're able to get and how many clients you're able to get through efficiently. Take a look at that peak TCP and the UDP throughput. On the right-hand side there, you're able to get almost double the amount of data through on a 5G versus your 5G and the 2.4G versus the 720. These are the same family APs, just one has the AX in it and the other is an AC. That's really what these two slides are for, is these are the same exact, this is the same exact family, just one's ratified for an AC standard, the older standard Wi-Fi 5 versus the Wi-Fi 6, and you see how much throughput that you can have using the same units, and just because of the technology. And then take a look there, 11% CPU load, because it's able to schedule this stuff. It's able to use its spare cycles to actually do something, versus the 720 just blasting everything, everybody, everywhere, no matter what it is. And then you get the IoT, those small packet units. Again, you're able to get those in and out quickly because you're able to splice up the spectrum. So with that, I think we've got about 2 more minutes here. We got. I want to make sure that you guys know Ruckus has a free 60-day trial for your school district. You're allowed to have 1 AP per school district to try out. If you want to take advantage of this and you want to see the technology and you want to see how the interface and how Ruckus works and how Verteks works, contact me. There's my email address right there. It's jchilders@verteks.com, and that's my direct number. It's 352-482-1460. That gets right to my phone. Also, if there's additional items, again, I apologize for the quickness I had to get through this. But if there's additional, if you want to get more in depth as far as Wi-Fi 6, please reach out to me. I can get Terry from Ruckus to get on with us and go through the what I call the detailed data on the units and get more into the weeds, which I like doing. But I just wanted to make sure that I tell you exactly what Wi-Fi 6 is as a high-level overview. With that, thank you. I don't know if we got 1 minute here. I'll go ahead and put on one question that I always get asked, other than are these devices shipping, which we touched on already, is cabling. Do I have to change out the cabling for this? No, you don't. To immediately take advantage of an AX, you don't have to swap out your cabling. Now, do you need to think about swapping out cabling and also you're switching at some point in time? Yes, you will. Just because now we have the new standards. We have a 2.5 gigahertz throughput on the switch port. Switch is coming out with that standard now, and you're able to throw more data throughput through an AP now. But you're able still to get that efficiency of an AX or a Wi-Fi 6 device. The efficiency is what we're talking about. Being able to support multiple devices or more devices with the same AP, or with a new school, the rule of thumb was to have one device per schoolroom. You don't have to have that anymore. You don't need that anymore because we were talking about increased efficiency. So with that, I will conclude